National City of Elections, and in this video we are going to talk about this. We're going to continue from where we stopped, and that's the B parts of what's happening. B parts of this example. Okay, let's scroll down. Okay, now when power factor is 0.8 lagging, I think lagging is the A part, leading should be the B parts. Okay, the A part is unity, and then the B part is when the power factor is lagging. So we've done when the power factor is leading. Now let's work on when the power factor is lagging. So when the power factor is lagging, note all we have to do is, it's kind of same process. Okay, first of all, this is the power factor. We've been given that the power factor is 0.8, which equals this. Now all we have to do at this point is to find the meaning of phi r, and that's just by taking the cos inverse. I should divide both sides by cos, so that phi r will be the subject formula, and the cos inverse of 0.8 is this. Now we've already calculated our current to be 80, that's the magnitude. Then since it's lagging, this will be negative. The phase angle for current will be what? Negative. So we have that negative there. So at this point we just have to substitute in the value of current into the formula for voltage. So of course this is given in the equation which we've done in the A part, and then this also calculated the impedance in the A part also, and then this is the difference. The difference in the B part is just the value of the current. To be specific, the phase of the current. Okay, and since we now have this as the phase, so of course this multiplies this, gives you this, and this plus this will result to this. Okay, and then of course this 25, and then we'll change this to what? This is in polar form, like this. This is in polar form, and a simple way to recall that's in polar form is that you see an angle. This is an angle, please. Okay, this is an angle. This, oh boy, what's happening? What? Excuse me. Stop lagging, please. Okay, yeah, so degrees, this in degrees. So once you see an angle, okay, angle and magnitude, you know this is in polar. I use a very funny way to recall this thing. So polar form, yeah, this is how I used to recall it. So once you see angle, you know that in polar form. Okay, then of course when you have it with J, you know you are in rectangular form. So we'll convert this into polar form so that we can add this. It's just like the example, it's just like the A part. Where is it? Just like this A part, what we did here. All these things we explained, just like the A parts. Okay? Oh boy, why are you lagging? So we do that same thing here. Convert this thing to polar. So with a rectangular, we'll have this, which is simply cosine of this multiplied by the magnitude. That will give you the real part. That's what we are doing here. Give us the real part. Then sine of this multiplied by the magnitude, which is this. That will give us the imaginary part. And then you can now add these real parts together and you get this. And then you convert this rectangular form to polar form. By doing this, to get the magnitude there, and then to get the angle, you do this. The imaginary part divided by the real part. You take the tan inverse and you get this as your angle. So Vs, this will be the new value for Vs. Okay. Now to calculate the power factor at descending end. power factor at the sending end, of course, we first of all calculate what phi s is, and of course that's the difference between the phase angle of the sending end voltage minus the phase angle of the sending end current, and that will give you this. Now you can take the cos of this, cosine of this, which will result in this 0.8036 lagging. Why? Because the phase angle of the receiving end current is less than the phase angle of the sending end voltage. Less than the phase angle of the sending end voltage. Okay? So that's the B part. So let's just go into the C part and see if I complete this. So for the C part, what's the question? Scroll up, scroll up, scroll. Yeah, the C part, which is the last part, 0.8 leading. Okay, so the leading now, it simply means, of course, the same process, exactly the same. But when we hear the word leading, it means the angle of receiving end current will be what? Positive. If it's lagging, the angle will be negative. If it's leading, the angle will be positive. Okay, so that's just the difference there. Now, with that difference, the rest part remains the same. But because of this difference in minus, that's this difference we have here being positive now, this difference now will affect the sum of these angles, and that will result in a different angle. So when you take the rectangular form, you have different values now, and then you sum this up, you get this. You take the polar form, you change it to polar form by getting the magnitude, and then you have this as the magnitude, and then you take the angle, tan inverse of imaginary parts to real parts. I'm just rushing this through because we've done this. Going into detail will just be repetition. Okay, I've gone into details in the previous video, so that's I'm just stating this point after point. Okay, and that will give you this. And then power factor at sending end, of course, exactly the same process, and then the phase angle of the sending end voltage minus phase angle of sending end current, that will now give you this. Now we'll say it's leading. Why? When you take the cos of the cosine of this, you get this, and we'll say it's leading. Why? Because the sending end phase angle of the sending end voltage, which is this angle, is less than the phase angle of the sending end current. Of course, this is the same. IR equals IS for a short line. It's the same. So we can even put IS here, it's still correct. Alright. So that's why we say it's leading, because the phase angle of the sending end current is higher than the phase angle of the sending end voltage, so it's leading. Okay, so that is for that part. Now the next question is, okay, that's for 3-phase, so we'll do that in the next video. Okay, so this is all for single phase, and I hope this really helps in a way. Okay, so thanks for watching. Subscribe, like, share, comment, and I'll see you in the next video. Bye for now.